This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Lesson 10. The Week 3 Capstone. No new theory. You already own the toolkit. Fillet and butt welds, weld groups and bending and torsion, weld specs and symbols, bolted joints and shear, fastener groups, threads and bolt strength, tension connections, bolt torque, and adhesives. This lesson is about using it under exam pressure, naming the attachment family in seconds, clearing the failure mode gate that family hides, reaching for the right area or formula, and checking before you commit. We'll rip through 4 fast problems that span the week, then lock in the lookup discipline, the traps, and the time budget. The method first. Attachment problems aren't plug and chug. Each family hides a decision you have to make before you touch a formula. Welds. The throat carries shear, so treat the weld as a line, scale the unit properties by the throat, and vector sum the shears. Bolts in shear. 4 failure modes on 4 different areas, and the lowest capacity governs. Bolts in tension. The strength lives in the thread, so read the stress area from the table, and remember the bolt feels only a fraction of an external pull. Adhesives. The bond works in shear but fails in peel, so design the joint. Name the family, clear its gate, and the formula is forced. Problem 1. Welds. Recognize a weld group and clear the gate. Treat it as a line and scale by the throat. Read the unit's second moment off the table row for 2 vertical welds. Then scale it by the throat to the real second moment. The bending stress is MC/I at the far fiber. Add the direct shear as a vector and compare the resultant to 4/10 of yield. It passes with a factor near 1.6. Forget the throat scale, and the stress is off by a whole factor. Problem 2. Bolts in shear. The gate is 4 modes on 4 different areas. Never reuse one. Bolt shear on the round cross-section, rupture on the net section, bearing on the projected rectangle, tear out on 2 shear planes. A mode's capacity is its allowable times its own area, and the lowest governs. Here the edge distance is short, so tear out is the weak link, not bolt shear. The joint passes with a factor near 1.3, rank by capacity, never by raw stress. Problem 3. A fastener group. The gate is the 2 shares. Slide the load to the centroid and add the couple, load times eccentricity. Every bolt gets a direct share. Load over the number of bolts, plus a moment share, m times its radius over the sum of squared radii, perpendicular to the radial ray. On the loaded side, the moment share leans into the direct share, so add them as vectors on that critical bolt, then divide by the shank area. That worst bolt sees about 57 megapascals. Size the whole group to it. Problem 4. A bolt in tension. The gate is the thread. Read the tensile stress area and the proof strength from the tables. Never compute the area from the nominal diameter. Multiply for the proof load. Scale by the reuse fraction. This joint is permanent, so 90%. Then multiply by the coefficient and the nominal diameter for the torque, picking the coefficient by the lubricated condition. Divide inch-pounds by 12 for the foot-pounds a wrench reads. A dry bolt would need nearly double the torque for the same preload. Lookup discipline, where everything lives. The whole week sits in 2 handbook sections, welding and joints and fasteners. The weld properties table and the 4 shear failure modes are the 2 pages you'll open most. The stress area and strength tables carry every tension and torque problem, and the adhesive table closes the set. Know the neighborhood, jump to the page, read the row, and confirm. Never hunt mid-exam. Under time pressure, the time budget and unit hygiene. 80 questions across a long day means only a few minutes each. First pass, solve what you recognize, and commit. The moment you're stuck on the gate, flag it and move on. Come back on a second pass, and never leave a blank. Then the unit slips this week loves. Kilopounds per square inch to megapascals is times 6.89. Torque in inch-pounds divides by 12 for the wrench. Keep the stress area and strength in 1 unit system. And peel is a force per unit width, not a stress, so never compare it to the shear column. The review everything slide, every trap from the week in one place. Welds, the throat is 0.707 of the leg. Scale before you bend. and a fillet is checked in shear. Bolts in shear, 4 different areas. Never reuse one, compare capacities not stresses, and the moment shear is perpendicular to the radial ray. Bolts in tension, read the stress area from the table. The bolt sees preload plus C times P, not preload plus the full load, and pick the reuse fraction and the coefficient by condition. Adhesives, peel is a force per width, not a stress, and the bond works in shear but fails in peel. The Week 3 recap on one screen. 3 attachment families. Welds, treated as a line and scaled by the throat. Bolts and rivets, 4 shear modes and the fastener group shares. Bolts in tension, the proof load to torque chain, where the bolt feels only a fraction of an external pull. And adhesives, carried in shear but failing in peel. And the habit that catches most mistakes in each. Scale by the throat, a different area per mode, vector sum the group shares, read the tension tables, and keep the bond in shear with a factor of safety. Know which neighborhood each family lives in, and the lookup is a confirmation. That's a wrap on Week 3, Mechanical Attachments. 10 lessons across 3 families: welded joints, bolted and riveted joints, and bonded joints, welds and weld groups, weld specs and symbols, bolts in shear and in tension, fastener groups, threads, preload, torque, and adhesives. Then this capstone stitching them together under time. More machine design and materials weeks are on the way. Subscribe so the next one reaches you. Everything's at peprepengine.com. A cheat sheet, worked solutions, and a short quiz are attached here. If the course helped, please subscribe, and good luck on exam day.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.